Okay, it is future, and I'm back. And we are ready for day 3 puzzle. Um, oh, a long way to go, eh? This 10, I guess, is because it's the 10th year. It is 10th year. Okay. Our computers are having issues. So I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole toboggan rental shop. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? I hear you're a developer. Can you check our printer? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. It seems like the goal of the program is just to multiply some numbers. It does it with instructions like multiply x and y, where x and y are each 1 to 3 digit numbers. For instance, 44 and 46 multiplies 44 and 46 to get a result of 2024. Yes. Similarly, multiply 1, 2, 3, 4 will multiply 1, 2, 3 by 4. However, because the program's memory have been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instruction. Sequences like this or this do nothing. Okay. 1 to 3 digit. Huh. Interesting. Why is this? Significant white space, you say? That's always uniformly welcome by the programming community. For example, consider the following section of corrupted memory. Blah, 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 blah. This. Only the 4 highlighted sections are real mul instructions. Adding up the result of each instruction produces this number. Scan the memory, multiply, sum all the results. Okay, that's straightforward. Okay, so let's start like we always do. First of all, we'll create a new file, day3.swift, and we create a test for it, day3.test.swift. This test file goes to our unit test section target, and we're gonna want some input. Is it all one line? Doesn't really matter, actually. For parsing, we just ignore stuff that's not uh, this, right? So 1 to 3 digits. So could be a regular expression, could be something else. Why does this sort before that? Oh yeah, day 2 txt test. Okay. Sure. So we have a test and we have the file on the left, and we are going to create a struct day03. That's a solver. and let's implement it. We need to define type aliases, right? So type alias for our input is just string, and type alias for our output is an int. And now we can generate all the functions. Why does it not suggest solving? Because, huh, sure. Okay, so I want to write an extension for the solver, by the way. Let's say solve part one. This is solve part two, and we also have parse. Um, so these are default implementations that we have. Let's have it here. Default implementations. So parsing from this, so parsing a string into the input type, where input is string. We just return input. So if we define input as a string, that means we want the whole string. Don't know if it's smart. Don't know if this is smart. Because this is generalizing before. Not sure if this is smart. Because I can imagine we want some other conversion from string to string. Yeah, let's not do that. Well, let's do this, I guess. So we're parsing from string to string. Um, so this just returns input. Maybe we want some kind of a tokens. And we want the function solve part one, return 0, and function solve part two, return 0. And I am not really sure why doesn't it use the types from here. Why does it resolve them into what they are instead of using associated types? Interesting. Okay. So this should be function from input to output, and this is also from input to output. Uh, sure. And with tests, we import testing, and then we do a testable import of our app, and then we can define a suite for day 3. That is a struct day 3 tests. And we have a test function that says example part 1, where we are going to copy this string and say that's an input. And we're gonna call solve part one on this input and say that this is supposed to be 161. And we do the same for part two, but this is something crazy. So cannot convert. Oh yeah, this should be equals, of course. I'm used to other testing frameworks where you give two values, what you expect and what you want. What you got, what your actual value is, and what your expected value is. But here, instead of giving two arguments to expect, you write it like this. Swift magic. And we're gonna copy this part from for day 3. And this is 0, this is all minus 1. So all of this should compile, but it will fail. Except we need to import foundation, and now we can run it. Okay, everything is failing. So we have this string, and we wanna parse out these ones. So two options. One is to do it with regular expressions. Uh, 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 uh. And we can easily write a regex to get this out. The other option is to not use regular expressions, but hand roll a parser where we have a state machine that first looking for x small, open parentheses, 1 to 3 digits, comma, 1 to 3 digits, close parentheses, and then ignore everything else. That sounds fun. And if I'm looking at two options, the one that would learn me more Swift would be that one, doing your own parser. However, I also want to do some of the later problems as well here. So I don't really want to spend a lot of time and in the end solve a very simple problem. So we're gonna go for the regexes, and I also don't really know enough about regexes specifically to Swift in Swift, so let's do that. So we're gonna parse uh, input. Well, we kind of have to see what day 2 is to know what, like, I was like, we can just solve it here, right? Get all the numbers that are wrapped in here and just solve it here, but maybe our output is not, input is not a string. So yeah, this doesn't feel smart. I'm gonna remove that. So let's have our input is valid multiplications. And we'll make a little file private struct. It's an array like this. I don't think we can make it file private because this is internal, and we cannot have something of less visibility in more visibility. Okay. So here we just have left int, well, actually 999. Yeah, just sequence int and right int. Right, and we have like result that is left times right. Also int. So how do we parse it? So we start with a regular expression that is in braces, starts with x small, literal parentheses, 1 to 3 digits, comma, 1 to 3 digits, and actually first digit cannot be 0, so it's actually 1 to 9 first, and then 0 or 2 digits. And that's our first capture group. And this is our second capture group. That's exactly the same. So we have this regular expression. We have all the matches. Input, I guess 3M matches. All matches? How did we do matching? Input matches off. Okay. So input matches off this regular expression. No white space allowed. Okay. And let's print. I think we map over it and we get output. What do we get? So here we're reducing it. 0.0.1. 0.0.1 value of type string element. Oh yeah, we have to go on matches, of course. 0 is a whole match, and this is first and second capture group, I imagine. Um, so match output 1, match output 2, and we int from that, and this to be has to be unwrapped like this. And I'm gonna print it actually before returning. And if I run this first test, I have 2 and 4 printed, and I need, oh, do not multiply. That is interesting. No, that is not. 5, 5 should be correct. Yes. 5, 5. Do we have 5, 5? No. It's only one item. Do we give a flag? So this is interesting. How do we match everything? So if I take the string, paste it here, and I take my regular expression and I paste it here. How do I make it match all the things? Hmm. What option should I give? Hmm. Regular expression match all occurrences. Do you have to like loop through it? Regex match all A's. Match multiple occurrences of a pattern. Pattern. Oh, so you want to match this and this, right? No, that's not correct. Do I need to make it global? Returns a match if this regex matches a given string. Matching semantics, what is that? No. Oh. Swift match all digits. I don't know. Maybe that's a good example. Whole match. Range. No, that's not correct. Uh, match all digits in text. Someone must have asked this. How to use regular expressions. No, 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 no. Different ways to check if a string contains another. Hmm. Yeah. Let's do a simpler regex, right? Let's just try to find all digits. Um, so any digit plus, right? What is the result going to be? Okay. So let's see what matches is. Is there a lot of matches? 12 matches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we do the same, but map it to int. Well, not the count, of course, matches themselves. 32, 64, 11. Okay. Now let's do the same, but instead of matches, we will have a regular expression. Uh, Input matches of this regular expression. Okay, we cannot do it here. So then something is wrong here, I guess? I don't know. Why doesn't it match what we want it to match? Um, let's go back here. One to nine, one of this, maybe that's why. But that shouldn't be working. 0 is, I don't know, second, first. How did they make this type safe? Do they parse this and compile this and then know what the capture groups are? So only one match. Interesting. Does this build? Um, so this builds. What about ours? Is it because of capture groups? Maybe it's because of capture groups. Only one, huh? What if we do not do capture groups? Um, So the problem is not capture groups. Is the problem with xmol? Okay. Wait, 2437 is not here for some reason. Because it's not in parentheses. 553264 is not in parentheses. 11885. And when we add xmul, then it stops working. So does it mean if I remove this? Ah, okay, so we need to say that this is a capture group that we don't care about. Never knew that. Ah, hello. I was I wanted to call you, but I forgot. And then I started. Someone I know was on the stream and I called them by their real name and they got upset that I'm revealing their identity. So I'm not gonna. I'll try to say May Helen. May Helen. What if I wait a second? I'm just realizing something. May Helen. Maune Len. No, that doesn't work. That's not a real word. You can pronounce it however you'd like. How do you pronounce it? Okay, so we need to say that this is not a capture group that we want. I don't understand why this works, but not having it, if I just say XUMUL, oh, I'm so dumb. We're looking for MUL, not XMUL, and there is only one XMUL here. Okay, okay. Classic. Okay, now it's not it's working. Okay, so X is not what we need. Okay, so then now if we run it, there should be more stuff here. 2455 11885. Is it according to specifications? 2455 11885. Yes, thank you. So we remove this. I'm gonna do this. What is 999 times 999? 1 million. And what is 2? Doesn't fit into 16, right? Needs 32. Okay. So we're going to do that then. What are we forgetting? We're forgetting a comma in here. Um, isn't not, oh, array literal. Okay, we're gonna do array literal. Um, oh, sorry. Array inside of here. Yeah, so this is a bit difficult to read. Let's do this. Cannot convert value input array of sims to closure result type. Oh, I have to say array literal. Okay, that makes sense. Cannot convert array of simmed ints to closure result type simmed ints. No, wait. Array of ints. Oh, we're making an now we're gonna say that we need to make one. Yeah, I'm making an array right away, but I need to make simmed 2 like this. Now this makes sense. Yeah, okay, and this is all garbage. Now it should build. Okay. Let's remove this. And we're gonna print it. And we get 2, 4. Yeah. Okay, so to solve it, we're gonna say input. There's probably a way better way. Can I do this? No. Um, can I do this? No. Can I do this? I'm trying to be smarter than I am. So we have, okay, let's not do this. Let's just sum it, right? So we return a sum. How do we sum things? I forgot everything. Now someone joined. Oh, there is not a 0 for this. Okay. Okay, so first we reduce. Now let's just do it manually, okay? Uh multiplied full width multiply. How do you multiply this? Yeah, that's not how it works, right? So what I was trying to do this, but I am doing it in wrong dimensions. So you have two numbers and you want to multiply them together, right? So you want to have a times x, but you also want b times y. So you can just do it individually, or you can do this. You can make two whatevers, and then multiply them together. And that will happen at the same time, and you get a new box that is this times this plus this times this. But I have created ax and by. So I will get a times b and x times y. So I actually needed to create something other than what I did. So that's being too smart. Okay, so we're gonna go back um, to this. Hmm. And just create a bunch of this. As we had, so this is left one, this is right one, and there are probably better names when you multiply, something like multiplicand and multiplicati. What are the operators of multiplication called? Multiplicand and multiplier. Interesting. Cannot convert value because we need to say this. And what we're going to do is to just take result there. Cannot convert key path into a multiple argument function. Okay, so what we want is we want to sum by result. Um, okay, so let's make that, I guess. Sum by, it's a function from element to element. So this, I guess. No, so we start with 0 and we get accumulator and the element itself, and we return this. Yeah, because plus is then defined. You plus this to here. You cannot use key path because you need to get two arguments. Okay, so now this should build. Uh, huh. But now sum should return the element. Ah, you are right. So it says that sum returns the element, but we actually do this, right? And we have to say that t is also like this. And we should use our function. Okay. Okay, does it make sense? So what we do is that we convert an element to something else. So based on the element, we calculate a value and then we sum all those values. So the return would be whatever this function returns, which could be the element, right? I think this could be like this actually, right? Because this function, okay. this plus becomes this. No, that's not correct. That becomes unary plus on element, so it is not correct. So now it should be good. Let's see. Do we get 161? That valid multiplications conform to additive arithmetics. Yeah, that is not really needed. Uh, from element to t. And to call this, oh, okay, this doesn't really have to be. So what we have is we have an extension for when the element can be plussed. But our struct in here, there is not plus defined for it. But because we have this, we don't need to have a plus. We only need to have a plus on this one. So basically, this is map by this function and then sum. Um, so we don't need to restrict it. We only need to restrict this. Compiled. Will it sum correctly? It did. Okay, and what is so we have -1 here, but now we are getting a bigger number. Okay, let's see if it's correct. Like a month and a name. Okay. As that took a while. May Helen. Okay, we have a gold star. Aren't we nice? Okay, let's add it also in here. So we added day 3, so that should work. Are there underscores in Swift? Okay, this should be scrollable at some point. Okay, what is part 2? As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you'll need to handle. The do instruction enables future mul instructions. The don't instruction disables future mul instructions. Only the most recent do or don't instruction applies. At the beginning of the program, mul instructions are enabled. For example, this is enabled, this is not enabled. This is do not mul. And now it says don't. So it's a different input for day 2. Okay, that's good to know. And in here it should be 48. Are you working today? May Helen. The corrupted memory is similar to the example from before, but this time these 2 are disabled. This one and this one. including the one at the end that gets re-enabled. Okay, what do you get if you add up all of the results of just enabled ones? Okay, so this is where this parsing is not really helpful to us. We need to parse it differently, right? Well, we still have valid multiplications, I guess. Okay, let me do this for a second. Um, I'm just quickly gonna save this. Do I get to also have a different input? Although it hasn't changed, you can still get your input. Okay. Um. So I'm thinking. Here's what I'm thinking. So you have a do. So what you want is a stream of things. Okay. Instructions you recognize. So from the parsing, you just want an array of instructions, right? And it's do, and then maybe it's don't, and there is some garbage that you just ignore. Um, and then there is a mole, and maybe there is a mole here. So, and you only want the ones that are after do, including there is like implicit do here. So this would allow you to have the same logic in here and in here. Or you can also say, oh, we have a don't do anything until mul. Okay. So we can do a regular expression that is a bit crazier, but I don't think so. So it's either do or don't. So if we make an enum here, it can either be a do, it can be don't, and it can be a multiplication with left, that's an int, and right, that's an int. And we already know how to make these ones. And we just have a bunch of instructions. And we need to parse this string into array of this. So we can write a very slow parser. Right, so the parser can either be accumulating characters, aka waiting for instruction. It can be waiting for first parameter, waiting for second parameter. Is this a good idea to write parsers like this? I don't think so. Or it can have an instruction, I guess. I don't know if it's, I know it makes sense. And it has an instruction. I guess. And then you go and look at the symbol. So if you're in this state, you can either go here or here. Hmm. So it's one of this. It's one of this. And then 3 digits. Up to 3 digits. How do you write parsers? Okay, let's think about it. So we have an array, and then 4. So let's write something very strange first. So state would be waiting for instruction. Right? We'll start with waiting for instruction, I guess. And we can just change the state like this. So we give a character and a buffer. And we get a new state and a new buffer, I guess. And it returns a new character and a new buffer. This is where we need a struct. Wait, let's just do return 0 here for once, for a second. Yeah, I always trips me up. Um, cannot assign value of type character. Oh, you cannot do it like this? Yeah, we need to return new state and new character, right? Yeah, wait a second, compiler. So let's see what will happen here. Let's write a little test where if we just say mul1 2, and then we say that when we parse this, we expect to get mul of, I'm gonna remove these labels because they don't really matter, 1 and 2. And then we say do up, and then we say don't, and then we say potato do not dance. So this is what we should do. Um, I'm just gonna say enable, disable because do is a keyword. And maybe we want first to always be enable, and even though it's not there, then mul, then disable, then enable, then mul 10 10. Right? So let's say this. Um, then do again, then some kind of mul that's a bit corrupted. So 1 2 disable garbage 1 2 3 1 2 3 do. Yeah, okay. So if we run this with a breakpoint here, requires that instruction be equatable. It is equatable. Why is it not building? Enum cannot be used as an attribute. Oh, yeah. Let's not name it state. Or make it file private. Okay, can we finally build this? We did build it finally. I'm already like, okay, going character by character in a string is not the best that we can do. Okay, it's running. Oh, it's waiting for debugger, and first time is always takes forever. Um, So starting here, okay, I guess that's fine. So now we just need to implement this. Or I'm gonna say that if next state is not the same as current state, print state. Print state and above. Don't need to print. Binary cannot be applied to two states. Well, sure it can. Here, please apply it. Mm, 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 mm. Okay, so we need to do the transitions, right? So how this would work? So based on the current state, right? If it's waiting for instruction, we need to look for mul, do, and don't. Then um, if it's do or don't, we're waiting for empty braces for do and don't, or waiting for two numbers. This is not a very good way to structure this at all. Okay, so if we're waiting for instructions, can we do car plus buff? How do you append to the beginning? Well, can I do car plus buff? Can I do this? Okay. Can I do this? Alright. Um, this is so wrong what I'm doing. If it's more than 1, 2, 3, 4, 5, um, this is so not going to work. Um, so what? Okay, maybe I should talk through this. So we're going to consume characters unless we get to Um, okay. And then kind of everything else we don't really care about, I guess. Uh, I don't think you need case. Do you need cases? Um, we return waiting for instruction, comma, empty buffer. Um, okay, and then when we have D, we just add it to a buffer, I guess. Self and D. Single quoted string literal. Well, yeah, that's not really going to work because now we cannot distinguish between where we have do or we're going to don't, right? So we need like this, stuff like this. Um, this is so bad. This is not how it's supposed to work. Cannot convert string to characters. Can I just give characters? That's tricky. Swift get characters from a string. Swift convert string to array of characters. Oh, array of this. Okay, makes sense. Hmm. So this is interesting way to parse stuff. This is very bad. Um, I don't really know. Um, what I'm going to do with it. But okay, sure. It's only three, so we can try. Um, so I imagine we can just kind of do this. Um, oh wow. Then we don't have to handle anything else. So, and now we just need to do multiplication with all the possible million digits. That's right, that's how it would work. Um, do I not do this? Why is this switch is not exhaustive? Oh, this switch is not exhaustive. Sure. Just get stuck, get stuck, get stuck. Hello, Unlord. Welcome. How are you doing? I am descending into madness. Would be a very picturesque way to describe this. Um, okay, let's just kind of try it, right? Just for fun. Aren't we all? Indeed. So it's array of instructions and then if let instruction equal third one or second one. So that's already also going well that we have tuple of 3. We're going to say append instruction. Sure, should work to some degree, right? So we should parse this at least. Uh, didn't build because we are returning something wrong. This one we need to return instead. We'll build now. Oh, you did build. Okay. Well, I hope we get some of this. So this is what I mean with not with building Swift intuition. Like I kind of understand parsers and I kind of understand Swift, but then the things are coming together. Something in my brain doesn't click. Okay, some of it worked. We have enable and disable and stuff. Oh no, it returned empty array. Sure, because I maybe should return an array of instructions that I parsed. I'm doing Advent of Code, but instead of, but I'm actually learning Swift is what I'm doing. So I just making an app. It doesn't have to be an app, but I'm also learning how to test stuff. Um, what did we got? Is output breaking or am I breaking? Like it shouldn't return an empty array, but it says it returned an empty array. Um, that's unfortunate. So it never got here. Waiting for instruction. It's always here or what? And it never got here? Oh, that is unfortunate. What do we have here? Let's not print any oopses anymore. Oh, I'm doing it the other way around. I'm building reverse of the strings. Um, yes, something. Disable, enable, and this enable. Yeah, so we said we want to start with enable. We always start with implicit enable, just for fun. Okay, so something did happen. But now we need to switch for M um you I'm telling you right now, I am not going to be refactoring this later. So in this case, we clear the buffer. There is not a command yet, but there is a new state waiting for first number. This is a very bad way to parse stuff. So I am afraid to do what I'm about to do. Well, basically, we have a string like this. Right, let me do this. Right. Or is it a joke? Is it being too advanced a joke or because it probably is, right? So you basically have a string on the left. So this is whole string, just multiple lines. And you want to parse it into some kind of a structure, right? So what I'm doing is I'm reading the string line by character, right? And then, oh, we have like two numbers with commas. Then we can convert it to this. That makes sense, right? Oh, we have some garbage here. We can just ignore it and pretend it never existed. Oh, but now we have this that we know what it is. We convert it to this one. So you want to have a structured array based on text. That makes sense. The way I am doing it is very bad. So normally what you would do, you would parse first. You wouldn't go directly. You would parse it to like a word, and no matter what it is, and maybe it's potatoes, right? So you would have output of like mole and don't, and then open brace and then close brace. And here it would be you start with mole, but you would have mole open brace 1 comma 2 close brace, and then you would go through this and then say, oh, this belongs together. So that's actually this one, right? And this don't, it also belongs together. That's this one. Oh, but then you have like potato underscore do, and then brace and the word note, something like this you would have, and then the word dance. Oh, this is just garbage, you would say. Or you would say, I don't know what potatoes are, but this brace doesn't belong to anything, so that doesn't make sense. And then this note, I don't know, and this brace, I don't understand. Yeah, it's from Advent of Code. Um, but this is like kind of super naive approach to parse code, right? You write some text, it needs to internally emit some stuff. And then in the end, you like build a tree that you have a mole and it has one in it and two in it. And maybe you have addition as well. So maybe you have a code like this, right? Maybe you have mole 1, 2 plus mole 33, 49, right? And you want to calculate that. So you would have like plus, and on one side is mole, and on the other side is another mole, and this one has 33, and this one has 45, right? And then you can kind of go and understand it in this format. So it just goes through a bunch of different stages. First, you split this text into like parts like this. Then you build something like this instructions. Then maybe you build a tree. And then on your tree, you can see, oh, this multiplication of 1 by 2, I can just replace it with 2, right? Because it's not a variable. I always know this value. And this I replace with another number. Oh, but then we have just two numbers and we plus them. So I just replace this whole thing. So that's like kind of what optimization is in compilers. But before you get there, you have to go through like a more machine understandable format. I don't think it's a hard lead code problem. But it seems like how I'm doing it is very stupid. And the way that I have all of this stuff is just making it way, way, way more complex. There is like a way smarter way to do this. For example, now, like this is not how you would have done it. Toby, Toby, don't leak. Uh, so this is interesting, right? So I think one, we can just stay with one. That is not true. Okay, what I'm thinking about is that you shouldn't have multiplication and then 0, 5, 0, 7, right? Because this is not valid number according to the rules. But you can also not have like 0, 7 in an abstract. If you just have 0, 7, it doesn't make sense. That's why we have the states. So looking for numbers only makes sense when you're not looking for instruction. So that's why you have waiting for first number, right? So we have this code, I guess. Um, yeah, this is just so stupid. This is just too confusing. Let's try to think of a smarter way to do that. So we can split a string But that's going to be a dead end to splitting a string. As this is kind of it's a like this is a little bit stupid, but this is not. Maybe this is not good. So we don't wait for braces anymore. Mm. And this is also wrong because uh, we keep the null, but we want to go here, here. And then we start waiting for number. Um, okay, no, and we reset our array. So what we're doing here is that we go character by character and we remember some. So we start with empty buffer and then we see a D. So we say, oh, we're still waiting, but now we have a D. And then we have O as the character. So we would have D from before and O here. So we'll have do. So it's like, oh, we're still waiting for a brace. What if you get the word instead of characters? Yes, so that's we going, so we handled all of this. So we don't have any other instructions. And again, the way that I'm doing it inside is not smart, but the whole idea is that first you wait for instruction, and then depending on the instruction, so this doesn't have any arguments, you can just say, okay, we found a new state, which are waiting for next instruction. Let's just make it here. Let's make a new one. And now we clear the buffer. We're starting like from scratch. And we actually parsed enable. We consumed an enable from do. Same for don't. But now when we have mul, we say, oh, we are waiting for instruction, but now we're going to be waiting for the number because we need 3 digits, right? And now we go to a different case here. So we forget all about of this, right? Now we know that we jumped from waiting for instruction for waiting for number. And now we have to do like different, now we have to check different conditions. So this is basically a state machine. And now we only have two things. We can wait for instructions or wait for numbers. So when we wait for instructions, we just ignore all numbers. If there is one, we just end up here, which like, oh, okay, this is wrong. So we either end up in a new state or we clear the buffer and start again. So when something doesn't match, we start again. So now we're going to be in a state that's not waiting for instructions, that's waiting for a number. And then as soon as we have a word, we just discard everything. And we go back to waiting for instructions. But I think maybe you're asking this, right? You're asking this. So correct me if that's not what you mean. So let's say you found an MUL with an open bracket. And now you go to wait for a number, but then you see the X there, right? What do you do? So at this point where you see an X, this doesn't really matter because we don't care. We just in the end, when we waited for a number, we will say numbers are only with multiplication, and we found x and y for numbers. But now we see an x and we know, oh, this doesn't make sense anymore. Go back to waiting for instruction, but maybe with this X. Because what we can have is we can have mul, comma, and then do. So what this would mean that this was garbage, but this was actual instruction. So we shouldn't discard this. We should start waiting for instruction with this symbol. And we kind of have like a bunch of states. So waiting for instruction, waiting for a number, waiting for a comma, I guess, waiting for next number. And we just kind of jump through them. So if we find mul here, we go from instruction to looking for a number. And if you find a number, we say, oh, now we need a comma. And if we find a comma, then we have another number. And then we say we are looking for a closing brace. And when all this whole chain completes, we say, oh, actually, we now have a good mul with n and n. And then we go back and start again with empty. And this is kind of what you would learn in CS class about parsing. Like you just build this state machine where you can go from one to another and different rules apply within each node. And once you transition, you don't really have to remember this part. So that's how you can split it. But that's also why some compilers have very bad error messages, because they see mul and then they say, okay, now we need a number. And they just discard all of this, because by knowing that they look for a number, they know it's mul. But now if you forget how you got here, you lose an ability to say, oh, this was at line 33 where we found mul, but then we couldn't find a number for it. Right? So they just say not a number, which doesn't make sense within context. So that's also a reason why it's a little bit not advised to go like straightforward like this to instructions and really build a tree and remember where you found what. Okay, but when we're waiting for a number, can we say if character is digit? Is number a boolean indicating whether this character represents a number? The character is not a number. The character is a digit. That's funny that they have is number, but also they have is hex digit. Well, I guess F is, well, it is also a hex number. Okay, someone file a bug report. Oh, oh, that's not what I expected. We're not looking for this. Is ASCII and digit. What is whole number? 1. Digit 1 is a number. But this is tie digit 9. That's cool. Okay, let's remember that it's a digit. Now we have to see, here's all the digits, right? So this is all the digits so far. So now we will have a string like 1, 2, 3. But first, first we have to handle a case that you mentioned on Lord, where we have an mul and then x. So what we want to do, or let's say d, let's this, right? And now we're looking at this one. Oh, we are in waiting for the number and we found D, because it could be a valid command, we should actually like restart with this. So we shouldn't discard D. We shouldn't skip one. So if it's not a digit, uh, go back to look for instruction. Yes, indeed. So we go for looking, waiting, waiting for instruction. Uh, but we should remember to keep this character because that instruction, so because of this case, right? If we see X, that's garbage. Oh, this is not gonna work actually. Sorry. Okay, so let's first implement it and then we're gonna okay, so implemented it. Um let's just reset everything. So it built. So what could happen? I think this is not going to work anymore. Uh I think we will break this. Let's say what will happen is that we will have a D. From here, we would be looking for instruction, and we will start with D already. And when we start with D, we'll hit one of this, so that's fine. Yeah, yeah. So it will send X, exactly. So you got it, but I haven't gotten it, so I have to talk through it, even though I understand. Yeah, so you get in here, you will start looking at buffer plus the next character. So if in here you had X and then do, you would start looking at XD. You would start looking at XD and you will discard everything and you will never match this do. So this will break. Let's do this. Mul X do, right? So in the test, we should parse this do still, right? Okay, that's very good. You are already checking for characters. So X is not valid, you can reset it. Yeah, so we have to check if it's a D or M, right? That's kind of would make sense. So we cannot have in the buffer something that's broken. That's definitely not gonna start a valid thing. That's the idea. So we realize that buffer is always like meaningful value. So we can only put in a buffer something that will start a command. So and that's only D or M. So we can say that. Let's say just this. Unlord idea. We'll just say thanks to. I cannot type. Thanks to unlord. New buffer is going to be either character or empty based on character equal D or character equal M. So this is why it's not a very good way to parse it how I parse it. Or another reason, I guess. You should really like parse it based on what is in between, what is on the boundaries. Oh, that's what we could have done. Would it help? I guess it would help. So okay, let's quickly because why I don't I'm hesitant to continue this because we will have to have a bunch of this. Oh, and if it starts with zero, if it's a first digit and it's a zero, it's not right. Or if it's like the fourth digit. Yeah, exactly. So if it's valid and then I don't want to like copy this here or extract it to another function. But what we can do, we can say, you know what? We are looking for this. We're looking for this and commas. And we're also looking for do's and we're also looking for don'ts. And we're also looking for uh, 0, 1, or 2 digit that follows 1 to 9. And then first we convert our string to just these words that are already valid. So we don't have to do it. I really like that idea. Does it make sense? And then we have an array. So this, what we have here on the right, would get converted to, oh, we have a mul and a brace and 1 and comma and 2 and brace. And then we just linearly go through this in this way. So basically we're eliminating all of this. And we only care about, if the rules are clear, maybe you can do an array of valid characters and check if the character you're currently observing is valid or not. Yeah, I can. So that's exactly. Actually, it is exactly this, but we even can go not per character, but per word, right? So, for example, let's look at. So we basically treat everything that's not mul as white space. Let's do this. Let's try it. So this is like a combination of ideas. So we have this. Well, actually, we can just take this. Let's do a little bit more. So we either want a mul or do or don't. It should be greedy. No, how do I do it? Is it greedy? Or this? Okay, it doesn't matter. Or don't, or comma, or open brace, or close brace. How do I do that? Okay, we'll fix it. We figure it out later. Or don't, or or 1 to 9 followed by 0 or 1 or 2 digits. Okay, so and here output we have mul open brace 1 comma 2 brace close brace do. Okay, so this is a problem. Why do I have do and not don't? Does it help if we change the order? It's so strange. Do, don't, do, do. This is the tricky part. Okay, so now if we just look at the green ones, this is super nice. And we don't get stuff like 103. Oh, we do, which is good. Because if we have this, we don't want, what will happen here? This is a bit tricky because we can have, yeah, we can do this. Yeah, yeah. So you're correct. I just do not know how to make it distinguish, how to make it, because they all start the same, right? I didn't know how to make it take the longer one. So look, if I say do or don't, right? So we're looking for do's or don'ts. Let's just do this. Either do's or don'ts. You see how here it went for do when it could have gotten don't. We can also look for this for NT separately and see when it's do followed by NT. Maybe that's something. Same thing with numbers. If we should only parse digits and not try to parse the whole number, because when you have 4 digits, maybe you want 12 and 34, or 1 to 3 and 4. So um so let's, I think we should, oh, I made a typo. Oh, I didn't. Okay, I'm just gonna look for an apostrophe T, okay? So there is not an intersection, and then later in our code we can figure it out. So I think this is good, and we parse this do. Okay, so we take this regular expression. Mm, we're gonna make a file private function. Yeah, let me do this first. We're gonna say for token in tokenize input print token. Okay. And now we need to make tokenize file private func tokenize, and we give it an input string, and it will return an array of strings. Could be also not strings but enums like this. Um, array of tokens. Okay, so we just say input matches of our regular expression. Yeah, but you will get the first word from string right. So if you have do, it will be do, don't, will be don't. If you have do, it will be do. If you have don't, it will be don't. And if you have do, don't, it will find the first and discard it because no brace and will clear. Yeah. Okay, this is also a very good observation. Let's see. Let's see how it plays out. So we have do and then n apostrophe t and then this. So what I want to achieve is that I never have to go back in this array. Because I see do and then I try to see if the next one is this, right? And it's not. So then yeah, I need to know for nt basically. What the problem was, yeah, okay, I get it. It can work like this. You look what the next one is. You're right. Um, you're right. You're totally right. My problem is that this gets ignored. If we look on the outputs, there are only do's here, right? There is not this part. Um, and we can say actually like whatever is there. Mm, no, that's not really working. Yeah, okay. You're totally right. The issue was that we just don't see this NT with how I chose to tokenize because with regular expression. But now I can, like, if we do something else and output stuff like you said, it can also work. Okay. So I'm gonna return match on this mapped to token init is what I want. Um, and I'm going to make it string based. Um, Actually, token init from raw value, which is output. Okay, this should work. Cannot convert. Yeah, force unwrap. Cannot convert regex output to expected. Yeah, we don't really need this capturing group actually. Do I need to do string here explicitly? Okay. Yeah, I don't need this capture group. Okay. So now let's figure out what the tokens are. Sure. Case mole. Okay. I'm gonna just quickly put some code in here so it builds. Because what I want to do, I want to print this. I want to print the tokens. Oh yeah, we're already printing the token. Okay, let's run it. Well, it will break because it cannot do some, because it cannot convert some of them to whatever. Um, is it running? Is it not building? What's wrong? Oh yeah, it is running. Yeah, so it broke because we don't have all the strings. Let me print this. This map to string init. This is just C. Huh? Oh, I cannot type regular expressions here. Annoying. Okay, let's. Okay, case do. Case nt. Right, like this. Case open brace. Case close brace. Let me type it out. Um, and then a digit. Oh, oh, I don't want to do this, definitely. I guess I have to. Okay, wait, I'll do it. Do you want? Oh no. Okay. Shall we do it smart? Uh, no, let's not do it smart. Let's just do it for now. Stupid. I think you can do some regex or something. There's no. Yes, that is true, but this conversion is not. I'm too lazy. I don't want to do this conversion manually. Okay, I'll do it. I'll do it. You're right. We'll do switch on a string of output. And in case we find a mole, we return mole, right? You're right. You're right. You're right. Case we find a do, we return do. Um, do begins. Let's just say do or don't begins. So this is do. This is nt. And then nt return nt don't ends, right? Case open. This is turn open brace. I don't know why. Sometimes I like underscores and sometimes I don't. Um, return close brace. Oh. And then anything else, we have say that it has to be it has to be one character that is ASCII and a number. Not otherwise it's not a digit, and then we can return a digit that is an int parsed from string. I have to put returns back because since I want to have this precondition. In num digit has no associated cases. What? I just meant token digit. Ah, it doesn't have. Yeah. Int. Okay. This should work. What does it say? First. Yeah, you cannot index with numbers. Okay. Okay. But Z and T should be only after you found do. Yes. Because if you just have an T and switch case will return don't. Yes, so that's why. So this is the first step. So first step to just parse out all the little bits that are meaningful. And then the second step is to go through all of them and convert them to maybe instructions. Because if we just return from here, right, that's exactly would be a problem. You just see like part of it, and then you're like, oh, that's don't, even though it isn't. So that's why I renamed it to, oh, if you see these two characters, right, it's either do or don't begins. Let's see, let's rename this. Begin, do or don't, right, and then don't. And you have to be looking ahead on the next token to distinguish between these two. So you're right, but that's for a later step. Okay, so now if we run it, we should hopefully see something reasonable parsed from this. Please work. Like it is better than what we were doing before. Ooh, comma, we forgot comma. Um, okay, try again. Oh, my hands are so cold. It worked! Look, 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 look. Haha! So we had a mole and then open brace and digit 1 and comma and digit 2 and then close and then begin do or don't and then end don't, open brace, close brace. Okay, so now we have all of this and we don't have to do those nasty switches inside. So now we have this, right? And now we can start looking at, okay. So we have a mole and then an open brace and then 1 and then comma and then 2 and then close brace. Oh, okay. These two look like something that we know what it is. Yeah, so before we had to like, oh, it's an M. Let's see if there is an U. Let's see if there is an L. So now we don't have to do it. We just know it's mole. Okay, I have to take a little break, though. But exciting, and I'll be back. Okay. Thank you, Unlord. You're helping me, so we're killing it. And usually, if you go to something like um, definition of what how language is parsed, you'll basically find exactly this stuff. Let's find something. Identifier. It starts with a head and then the characters, maybe. And then you see what is identifier head. Oh, it's one of the letters or underscore or one of this or one of this or one of this or one of this. So it's basically like in real world, it kind of works similarly to what we build, except they don't use a regular expression. They do it differently. Like there are tools where you give a list of rules like this, and in Swift it's just huge, and it will just generate code to parse those out from text. Um, okay, so we don't really need this being printed anymore. What we want to do is we want to start feeding um, this to our parser. So we have all the tokens. We don't need this buffer anymore. Um, well, let's just say our instructions, our list of instructions is just parse tokens, okay? And then we're gonna write that function. Let's remove this. And we don't need this struct anymore because all the data is an instruction. Okay. Let's make parse. Uh, so we parse a list of tokens and we return a list of instructions. Okay. And what we will do first is, wait, look here. Um, let's restart it from scratch. So we have parser state, and it can be looking for instruction name, looking for uh, yeah, let's see what happens. Uh, looking for number will be there, and looking for comma, no. I think looking for first number, looking for second number. Um, and maybe looking for call. Hey, Namari. How are you doing? We're solving Advent of Code and making it into an app. But actually, we're learning Swift. Um, checking teacher's PDF. About what? He's a really bad coder. Well, hopefully he's a good teacher. About full stack development. Okay, okay. Um, okay, we then put dots here. So current token is looking. So state starts with looking for instruction name. Yeah. Well, he got you excited to refactor the whole code. So he's doing his job. They're doing their job, not he, they. Uh, so current token is first token, and we're going to make sure the tokens have the tokens are not empty. Okay, let's write this. Um, he's logging database URL and pushing to GitHub. Oh, that can happen to anyone. um, okay. Current token is the first one. Let me think. So we switch the state, right? That we know. So what are you doing? What are we doing? We are looking at Advent of Code. And the current task is we have instructions like this. Well, not like this. We have like a bunch of stuff like this that might contain instructions like this. Multiply two numbers. Or it can also have garbage like this. That might be similar to instructions. And there are three instructions. One is multiply numbers. One is ignore multiplications. And another one, stop ignoring multiplications. And what you need to do is you start with not ignoring. You multiply numbers. So here you would do 1 times 2 equals 2. And then you sum all the results, all the products. But if you see don't like this, you should ignore multiplications that follow. And if you see do like this, you should stop ignoring them. And you can have like garbled inputs that you have to like parse out actual stuff. So here it says xmul instead of mul, so you should know that you should look here. And here it says some garbage where it's mul, but it's not a number. So you ignore it, but there is do, that prefix by this. So that's what's happening. And we now converted this whole text into things that we care about. So there is a mul, and then there is a brace, and there is a digit. And we need to go through this list and see if it makes sense. Okay, so when we are looking for instruction name, and let me do this quickly. Swift Xcode text editing experience. Precondition failure. Fall through, not implemented. So that just we don't get. And we need a dot here now. Okay, now it should build. Okay, so when we're looking for instruction name, we're gonna look at the current token, and we're gonna consume it, right? So while while we have tokens, uh, we need to be let's say input tokens. We need to make a copy because we cannot modify this parameter. So we're making a copy. That's the reason. So while we have tokens, we do this. And we'll make a couple of functions. Consume will return a token, and pick will return the token. Why it's needed? Just for convenience. But don't look at it yet. So consume will just say tokens drop first, remove first. And pick will return first. So just this. This is just convenient names, and we don't have to type all of this. Let's put it together. So we make a copy of tokens and we start going through state. Okay, that makes sense a little bit. Okay, so we take a token and we always take it, and then if it's null, we also need to return instructions, right? If token is null, we are going to state looking for first number. So we get a token. It can be MUL. So we say state is looking for first number. It can be do. I think unlord was correct. We need a bunch of if else's. If it's I'm confused. Wait, let's do first. Okay. Maybe we should write down it. Okay, so when we're looking for instruction, right? We only care for MUL, do, or NT, right? Because otherwise we just ignore it. and we delete it. So like if this was our list, it starts with comma, we just ignore this comma, it doesn't make any sense, right? We ignore this digit, we ignore this brace, now we care. And then depending on what follows, we discard them and emit either do or don't. That's the idea. Okay, so we look at a token. If token is MUL, we go to waiting, looking for first number. Or maybe not. Let's write it down. Else if token is begin, do, or don't, we do something else. And then else we don't, and otherwise we don't do anything, right? Okay. Okay, let's do MUL. And token can be equated. Else if, so we have MUL, we go for looking for first number. I cannot think about it right now. Let's do this. Um, up, up. So this is our token. I think you can do like if let second token return done. Yeah, exactly. I'm just having trouble with being tired arranging it. Yeah, you're right. So we are here. So we look at the next one, right? If token is begin this and token after it is equal to and don't. So if we have this situation, we remove this and we need to remove this. Um, actually, let's do this. So if we have do, that would look, how would it look like? We have do, and then we have open brace, and then we have close brace. Then we have to consume two tokens and add instructions, append, do, enable. Okay, let's make instructions. Okay, and we said we start with enable always. I think it would be better if you put a second if condition inside of token. Yeah. Do you mean this? Consume, okay, and we want to always drop count int tokens drop first count. Okay, what does it return? Sequence. Okay, so what we did, let's remove this. So if we found do, and the way we find do is that we say token, and it's do, and then the next is open brace, and then the close brace. Then we remove these two braces, and we found a command. Okay. Otherwise, we can also find don't. Token would be begin, and peak would be end don't, and then we have braces. Then open brace, and then close brace. I don't really like this, but let's roll with it. Um, so we have to remove 3 tokens. And instructions append disable. But we can also find an MUL, right? Else, if token equal MUL, we want to do state looking for first number. Okay, how does this look? I don't like this if stuff, but for now it's fine. Maybe I also want to say that there is an open brace, and then I also want to drop one. um, okay, and maybe that's enough here. Why I'm a little hesitant is that I don't really know what is a good idea. How deep into instruction should we try to parse, right? Because like we can say, and the next one is a digit, right? And the next one is a blah, blah, blah. And maybe when we are doing that, yeah, let's keep it like this, right? Because it seems that this could be a bit tricky for the same reason. Because now we are here, we went through here, and now we're looking for a number. And what if this token is do? So we kind of have the same problem where we had before MULX, right? But we're a little bit in a better situation because we cannot have X, right? We cannot just have random garbage. We have garbage that's somewhat more meaningful. So I'm curious how we will handle this. Okay, so looking for a first number, it means that we want a digit. Do we want to consume always? Uh, so that's a question. Do we always consume? I don't think so. because we might consume something good. Oh, something that should be like reset. You know what I mean? If you have mul and then do, you don't want to consume this do. You want to ignore this mul. So what will happen, we would consume it here. So this is our text, mul and then do. We look at this, we consume it. We'll look at the next one. Oh, it's a brace, we consume it. And now we go looking for a digit. And if it's not a digit, this is not a digit. Because at the beginning of looking at the digit, we consume this. We will never see it again. So this doesn't look correct. So let's do pick. And this 1, 2. And we drop 3. Do and braces. If it's do and braces, we drop it. Actually, this was correct. Wait. We shouldn't move it here. Here we always consume. Okay, and now the digit 1 should not consume. It should set state to, yeah, okay. So now it makes sense to me. Let me see if I can explain it well. So we went into MUL and we dropped this, so our array starts here. Then we go to, hey, we're looking for some digits, right? And we start and we look at it and it's not a digit. Instead of consuming a token, we should switch back to looking for instruction and start again from the same spot. This should stay. We shouldn't remove this. Okay, then it will work. So we want to pick and see that this is a digit. So maybe digit is pick. How do you do it in Swift? I don't remember. But let's say you do something like case let. If case let digit equals to pick, is it correct? Comma, digit more than 0. We consume the digit. Okay, that makes sense. We consume the digit. Okay, so we are in this situation and there is a digit. So this was already gone. And now we have to distinguish between this, 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 and everything else. So I guess what you normally do, you do consume number. You make a function just to parse that out so you don't have to repeat yourselves. Uh, okay, so we'll write it later. So you consume a number, and then, well, okay, let's think about it. Consume. So what we want is consume number, consume comma, consume number, consume close brace. And if any of this fails, right, you want to start parsing this again from the beginning. Uh, 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 uh. Interesting. Maybe we should call it not first number, second number, but just arguments. Hmm. Let's say mul arguments. I like that better. That makes a little bit more sense. And then we don't need this actually. Um, we just have two things. When you find a number, there are two possibilities. The next should be number or comma. Yes. But it gets complicated because there could be garbage, right? There could be like this. Well, not like this, but it could be like this. So we will need to understand this do, ignore all of this. You can also have a parser in a parser, I guess. But let's try. So if it was only one digit, that would be easier. Let's think about how it would look like if it was only one digit. We would say peak is a digit, right? And the next peak is a comma, and the next peak is a digit again, uh, and the next peak is close brace. That's what we would want, right? The problem is this number. This is not a one digit. It's 1 to 3 digits. So if it's 4 digits, it's wrong. If first digit is 0, is wrong. So there is some logic to parsing numbers. We can say um, we can say consume all digits, right? And then we say left number is consume all digits because it's a little bit not clean because we said what if there is do inside, but digits don't matter. Digits don't matter because comments, this never looks for digits when we look for instruction name. So that's fine. Um, and then we can say And same for commas, right? We can say consume comma, and then we can say consume all digits. So this will not do anything if it's not what we expect. And that is safe to consume. And then we can say consume closing brace, right? Actually, this is fine. Um, consume brace, whatever. All right, let's do consume all digits. While consume is digit, while case digit, no. Tokens drop returns a subsequence by skipping elements. No. What happens to numbers? Wait a second. I want to try this. Oh, because it's LED, it's actually... Oh, this is a bug. This will not change tokens. This is not correct. Huh. Wait, I want to check something. So numbers is the same. Annoying. Do I have to like remove? Oh, okay, so remove first. Maybe you one more switch case. In the case of 12, 1, first number is 1. Look for second case number, and then 2. Yeah, think you making sense? Yeah, so that's effectively it sounds the same. Um, Yeah, we can do something like this, right? We can do switch pick 1, pick 2, because we're only looking for 3, right? And then we can say digit D1 digit D2. We can do stuff like this actually. That's funny. Uh, that's fun. Right, so we have a 3-digit number, pick 3, right? And then there has to be a comma. We can do this, but it's a little bit unmanageable in the end. Let's try to make this first. So it will return a bunch of numbers. Let's see. Consume all digits. So var digits is array, while pick do pick if case digit let digit is equal pick drop and digits append digit digit. Oh yeah, append digit. And else we just go out of the loop. Okay. While true, empty collection requires explicit type. Yeah. Okay. Okay. So we look at the token. If it's a digit, we add it here. I think it would be better to just check the next element. Like in the case of 1, 2, 3, you find 1 and you look for next. If it's a number, you combine it and the next until you find a comma. Yes. So that is possible. Yeah, so this makes sense. Why I am not sure about it because the only way I can see it is to do it is to just write if we have a digit and then the next one after that is a digit, right? And the next one. So I don't want to write it like this because then you have to also like, oh, if this is a digit and then you have a comma, or maybe you have digit digit comma, or maybe digit 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 comma, and then you have to do the same for the second number. That's what I don't want to do. So it this is the same basically, except it's a little bit more just manageable to write down for me, right? So get as many digits as you can and return them all first. That's the first step. So let's see how that would look, right? So consume all digits. Um, then we say consume if it's a comma. Let's make consume if also. I also like creating these functions. I don't know why. Uh, I guess it's called drop if. And it returns a boolean. And then if pick is token, you drop it and you return true, otherwise false, right? Okay, that makes sense. Uh, and I guess we could rewrite all of this stuff a little bit better now. Okay, consume all digits, guard, consume if comma else return. Right number is consume all digits, guard, drop if, close brace, else return. And then we want to do stuff. We should not forget to say, first of all, we're not returning, we're continuing this loop. And before we continuing this loop, we're setting state to looking for instruction name. So shouldn't forget that. So we get a left number, and whatever happens after, consume all digits is always okay. Same is here. Whatever happens after, drop if commas is always okay. And here we can say um, let's not do everything all at once. Um, so we get all the digits, drop commas, get all the digits, drop commas, and maybe nothing or none of this happens, all right? Um, now, left number, basically removing commas is always okay. Removing braces is always okay. In this case. Okay, so now we want to check that this is non-empty and doesn't start with 0. Mm. Oh, I don't like that I have to write all of this here every time. Same for right number and does not start with 0. And now we can parse a number. uh, left digits, right digits. Now left number. I think a for loop would do it. We're here. With what you have in mind. I'm having a hard time like exactly understanding what you mean. I kind of feel it and I get it, but I can't like think about it in code. So that's also I'm not ignoring you. I'm really trying, but it's just parallel processing is not working. First number for int and if big first not big comes big. Because it's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I kind of get it. First number. To how to convert first number plus big. Yeah. I guess so. Wait. I'm gonna just for a second do this. I want to finish this and then we'll try to see how your solution would look. So first I want to append a multiplication of two number left digits and two number right digits. So that's, I'm gonna do that for a second. And I'm gonna make that function real quick. Digits is array of ints and it returns an int. And I'm gonna return zeros for now because I want to see what happens here. Does it build? Parse. Oh, that's different parse. Parse tokens. Mm, okay. And we don't forget to return instructions. I just want to see if I get a bunch of zeros now. um, yes. Look at this. Enable 00, disable, enable 00, enable 00. Okay. Something is going on there. Okay. Okay, so we have a for index in digits indices. Digit is digits. Wait a second. I'm blanking. So what I want to do is I want to have for digit and digits reversed. I want to add to the number digit times 10 to the power of number, like this. Exp power. No. How do you do that? Decimal to int. Okay. I'm getting a bit tired. Okay, and we have to increase power by 1. And this is just should be index. Element offset, like this. Wait, this should work. Oh man. What did we parse? F enable F enables and multiply 1 by 2, then disable Then enable again? Oh man, we made a horrible mistake. Well, numbers work. I'm happy. Oh man. Okay, I'm gonna rewrite. I'm gonna procrastinate and rewrite it. um. Okay. Let's not procrastinate. Var peak, blah blah blah. First now. Okay, peak is this. First now for peak count minus peak. You're doing reversal. Yeah, yeah, makes sense. Okay, so we made a mistake. So what we did, right? We had this input, and we generated this output for this. So our mistake was that we completely ignored everything that's invalid. So because we ignored this not, what we got instead is this do. So actually, this should be incorrect. But we got this. Or I guess this. Because our regex doesn't understand this. And we just dropped it. Well, so that's like everything else works. So now we only have to fix tokenizing. And we have to fix tokenizing by having garbage. So we have to add garbage. Um, we're gonna add garbage in a second. Man, it's been 3 hours. I don't know if I'm learning about Swift at this point necessarily, but I'll finish this. I'll finish this. Okay. I hope we're not going to find out that we could have done it way easier. Well, I hope we find out and do it. So, okay, let's try this. So we either look for do int or something else. Will it work? Let me try to see if it will work. Or anything else, all right? So otherwise, if it's a digit, if it's a digit, we return a digit, otherwise we return garbage. Will just this work? Um, and then in here, we just always do garbage? Will this work? Let's print out tokens. Kind of feels like it should work. Let's print our tokens and see what is happening. Toby, don't lick your paws. There is some garbage in between? There is some garbage in between. That's nice. Okay, so we got a mole, and then a brace, and then a digit, and then a comma, and then a digit, and brace, and then begin don't, end don't, and open brace, close brace, and then some garbage, and it seems like it worked. Sure. Uh, why is this wrong then? Let's see. Enable, multiply, disable, multiply. We only got 4. Huh, this didn't work. Oh, because, wait. Oh, this is garbage. This is just one thing. It doesn't see. You just don't. This is not really good. Uh, eh. This is not really working like this. So the problem is our regex, right? Let's see if we can fix it. Or something that is not any of this. Um, plus. So not is ignored. Single character. Now we don't need a single character, we need this. And do you do like this? Negative look ahead. Not really. I'm overwhelmed from studying, just hanging out. Yeah. Well, good. Good that if we find it entertaining. Um, what is all of this? Atomic group non-capturing. What is atomic group? I'm not the one who's coding. Okay. Okay, what is the way to do it without regexes? Uh, you just look through a string, right? And if you find mul, do, don't, or something, right? So basically the task is like this. Um, so you get an input string and what you want to do is find next of a find a substring. Okay, so if we go for characters in input, how do you do that? So if we only wanted digits and everything in between, right? We could say is number whatever. Uh, if it's a number, as a string, I mean, if you find do, it's an instruction. Yeah. Yeah, I just don't really know in Swift what's I don't know all the APIs, so it's a little bit confusing. But so I don't want to go character by character basically. I don't want to do what we did here, but for characters, right? So I don't want to do again like, oh, if it's D, then maybe the next one is O, and if it is, right, you have to see if it's N, comma T. Like I don't want to. Yeah, I do. I would like to do that. So this is kind of the same issue here, right? Where we're first looking for do and then for don't, but then it would always only do do's. There is not a single don't here. So it's kind of the same issue. How do we make our regex that we now use? So this is a regex we now use. How do we make it capture this, or anything else? Yeah, also can be do, and like we can optimize it a little bit with do's and don'ts. So we can have do, don't, and mul and digits. But the problem now is how do we like not ignore this? Because if we say any character, um, it doesn't work anymore at all. Why is it not working? What we can also do is to just go through this string until we find a single character that we care about and emit that, and everything in between is garbage, right? So we can just keep discarding this and convert it into one token that's garbage, and then we see MUL, we emit it as MUL. How we know, how do we check? That's a problem. How do we check? Let me take a picture of this. So we start going and we're like, this is nothing, 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 this is nothing. So this whole block, right, is just one token garbage. And then we see, oh, M. Maybe the next one is U. Maybe the next one is L. Oh, this whole block is MUL. Oh, the next one is a brace. Oh, the next one is a digit, but maybe there are two digits. So, and a comma, and another digit, and a brace. Oh, but then there is garbage again. So, how do you like look ahead? Well, I guess that's the answer. You just kind of look ahead. Um, let's see what people say. Convert, tokenize, string. How does this work? So they just read until space. What if you don't read until space? Yeah, it's just one character. Um, str talk. What is str talk? GFG is a string, and S is delimiter. Hmm. Maybe we can do this instead of. Wait, let me just take this for a second here. Can we split it on regex? We can split it on regex. What does this give us? What about word boundaries? Word boundaries slash B, you mean? Um, it won't work with stuff like letter do because this is not a boundary. What does this do? But instead of input, we do XMUL this. Unterminated string literal. Can I only it's not a string, it's a regular expression. It's not supported here. Annoying. Let's just call it. Let's just say print blah input and remove this for a second. Yeah, so this works kinda, but we only get new lines. We don't get potatoes. A little discouraging. Input. Has prefix, has suffix. Can do that. Contains index of. Okay, so I guess we can say input has prefix mul. We can do like something like this, right? Then we do this and remove 3 characters. And then if it has prefix do, we can say token this and remove 2 characters. Else if input first is one of the digits or one of this, that feels a bit stupid. But maybe we can just make it work. This is a little strange. This is very bad performance-wise. Makes me feel a little dumb because I don't understand what's a good way to do it. Uh, okay. Tokens is empty array of tokens. Yeah, Toby, you hungry? I know. I know. Give me half an hour, I guess. Mm, remove first 3. Tokens append this. Tokens append this. 3. And then else if copy first is ASCII and copy first is number, tokens append digit int from this Uh, digit and then else. So this, this, or this. Um, and open brace first. This is so bad, I think. Comma, and then if not, garbage is equal true. Let garbage var garbage is um, garbage equal true. Tokens remove first. Uh, so this is else. Else we do this. This is just something is happening. uh, okay, garbage is equal true, and this should undo garbage. Push garbage. So every time we find something useful, we do push garbage. Actually, no. Instead of token append, we're gonna add token. Add token of length 1, of length 1, of length 1, of length 1, of length 3, of length 2, of length 3. Okay. Okay, and now we need to do add token. Okay, so what I'm trying to do is I'm just going through a string uh, token is token and length is int. So I'm just going through a string and I'm looking at, is there a mul? Is there a don't? Is there a do? Right? And if there is, we remove it from a string and then we're gonna look at the next one in the same way. And if there is a garbage, we just one by one remove stuff. And in the end, we just drop over everything. So we marked it as garbage. So if there is garbage, we gonna get it back to false, but also tokens append garbage and then tokens append the tokens that were asked to and remove first length characters. So what I hope will happen is we will have garbage, mul, brace, blah, 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 garbage, don, do, and t, brace, 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 brace. You get it. Let's try and see what happens. But this is very, I don't like it. Oh, it's just empty, sure. Because we didn't return anything. Returns array of tokens. Okay. Okay, hopefully now something will happen. Okay, so there is MUL. Okay, and it on there has to be a loop, of course. While copy is non-empty, we do that. I was like, I shouldn't forget to add a loop. And I forgot to add a loop. Okay. Oh, I removed from tokens. We can remove 3 because we checked that first 3 is nothing. Okay, we just remove 3. Okay, let's see. Do some garbage? We do have garbage. Does it work? Yeah, this tokenize is not really useful. Mini map. Where's my mini map? That's why am I a little bit. Okay, so what should happen is enable, multiply, disable, then garbage. then multiply, then garbage, then enable, then garbage, then multiply. Toby. Um. Oh, instructions. Yeah. Wait, I'm gonna. Yeah, sure. Let's try it. It didn't work. Enable, multiply. Doesn't understand disable. Yeah, we need to test tokenize. Okay, so this is correct tokenize. But now tokens are mul, open, digit 1, comma, digit 2, close brace. Begin do, and don't, open brace, close brace. I guess there is garbage as new lines, but we'll see. Then garbage, I guess do, open brace, garbage, close brace, garbage. Okay, let's see. Toby, cannot remove more items from a collection than it has. I thought that's possible. Oh, I guess. This we need to do? That's a strange that it just doesn't remove everything. Oh man, what is this? Oh, there is two apps now. Okay, that's at least it's starting. 10 elements, expected 16 elements. Uh, why is it only 10? Let's do this. We print this token that we're appending. Mul open brace digit comma digit close brace and don't. Ooh, where did do go? Why isn't there this? Has prefix do this and comma t. Huh? We remove 3 characters, 2 characters, 3 characters, 1 character, done, done, done. We print this as well. Okay, comma digit close brace garbage and don't. Why is it and don't? Let me print copy first suffix of 3 of 5. Maybe this will help. I don't remove anywhere. Add token. What? Why is it dance? What? Starts in here. What? Oh, suffix, prefix I need. Okay. Mul, 1, 2, open brace. What is this? A new line. Digit 1, comma 2, new line D. Oh, it's a new line D. So new lines really. Wait a second. So we had this, And then we remove 3 characters. So we had this. Um, yeah, Toby, I know. You're a bit hungry, eh? Come here. Up. We have to try to finish this. You have to wait a little bit. Where did it do a close brace? Do I remove too much? Oh, because I remove by 3. I just remove 1. Okay, 16 here, 16 here, but they're a little bit. Hello, where are you going? Are you gonna type, Toby? He's like, I'll finish this. If you can't, I'll do it. Okay, let's check why didn't not work. Move. Why is this on one line and this is not? Yeah, and you're gonna be on the table now? Okay, well, let's see what you're gonna do. Hmm. Okay, now you're on a table, Toby. Okay, I'll make a picture of you, yeah? Okay, well done, Toby. Okay, I'm gonna put this in here. Um, okay, so it's mul open brace digit 1, comma digit close brace, garbage. Okay, so new lines are garbage. That's fine. Begin and open brace, close brace, garbage. Begin, open brace, garbage, close brace. Okay, so new lines are garbage. Okay, that's good. At least it's so garbage, garbage. I think now it should work, I guess. Well, not really. I think this garbage is not. Because garbage is collapsed. I think it will collapse this new line and this potato underscore into one. So new line. Yeah, just test it. Okay, let's just test it. Oh, this is now needs to be deleted. I wish they could show you a better div. '16 elements and this is 17 elements. Oh, it doesn't have this garbage. No, it does. Where is the difference? Oh, it doesn't have an end garbage. Okay, whatever. I don't understand why isn't there end garbage. Oh, there isn't end garbage because there isn't a call to. There isn't a call to add token. We only add garbage when there is a token. Okay, I'm gonna put it here actually. Uh, if garbage append garbage, so it just makes a little bit more sense in the test. Now I have this. He's very hungry. Okay, we're almost there. It's like final moments. Wait a bit. Okay, so let's do first day at least. Um, so first day, where is it? We're just gonna go and do all multiplications, right? So input sum by, and this is instruction if instruction if case mul a and b equal instruction, return a plus a times b, else return 0. Okay. Let must, how does this work? Huh? Input is array of instructions. Okay, does this work? This works. If case mul equals instruction, mul is a function that produces expected let a, let b. I always get confused. If let Swift. Oh, no. If let case. If case let. Okay. Cannot find mul. Instruction mul. Oh, you do this. Okay. Oh man. Okay, this should work, please. Yes. That doesn't work because so we just go for instruction in input, switch instruction. Oh man, that was difficult. Case enable on equals true. Case disable on equals false. Case mall a b. Sum plus equals a times b. Okay, so on an instruction. So if instruction, if it's whatever and enable, on equals true. If it's whatever and disable, on equals false. And then if it's true and multiply by this, we do this. And otherwise, we don't do anything. Okay. Finally. Okay, what is the result? This number. If it's not correct, I am upset. Wow, what a... Okay, I am going to commit this to GitHub, so um wow, that was something, eh? Okay, thank you for staying with me through this experience. We did a lot. I don't know if we have necessarily learned a lot, but all the code is here, and I have to go feed the dog. Thank you, Unlord, for being here. And I'll be back in the future. Okay, bye. And thank you for following, by the way. Okay, now bye.